Okay, Assalamualaikum and good morning. Okay. Today we will discuss on test 2. Okay. And make sure you check in your attendance. If you are in the morning session, you use UTM Smart and take the QR at the left side. And if you are in the evening session, you take the QR at the right side. Okay, we will start in 30 more seconds. Check in your attendance. Okay, we start with the first question, 1A, okay, the theoretical question. So if you can see here, you have been tasked to determine what type of load is conducted to the system. So the voltage source is 240 angle 0. So what is the current source? Okay, if the given current source is given, what is the type of load? So if you can see here, okay, this one you have to memorize. Okay, so you have to memorize back. Remember back for L. Okay, L load, the current will be 90° apart. Okay, for C capacitance, the current will be leading. Okay, and for resistor, the current and the voltage is at the same phase. So for in between, you know that, okay, if something, for example, like this means that it is a RL load. And for example, it is in between here, it is RC load. Okay, you don't need to do calculation. This is just memorize. You have to memorize it. Okay, so based on this, okay, you can see that the voltage is 0°, so it is easy for you to draw. Okay, so okay, for the first one is like this V. Okay, just ignore the magnitude, only look at the angle. So negative 90°. So this is I. So if you can see here, if you refer back to the figure below, before, it is L. Okay. So this is load L. So then the second one is, okay, this is V, and then this is I. So it is between positive 19 to positive 19 to 0. So this means that it is a RC load. Okay, and then the third one is, this is V, and then this is I. So it is in phase. It means that R. And then for this one, okay, so if you look here, this is V, and then the angle is 45. So this is between between negative 90 to 0. So if you refer back to the figure before, it is RL. And lastly, okay, voltage and then 90 degree I. So if you refer back to the figure before, it is C. Okay, that is how you answer the 1A question. Okay, next we go to the second 1B question. So for 1B, okay, if you can see here, the power factor correction is a method used to increase the power factor of the inductive load, RL, okay, to allow a variable typically above 0.85 prescribed by TNB. Okay, this is a supplier for the in Malaysia. Okay, this is done by installing capacitor in parallel to the inductive load, and the load current can be reduced, therefore reducing the losses. Okay, sketch the equivalent circuit. Okay, with the improved power factor and the phasor diagram. Okay, so basically it asks two things. Okay, it has two things. First, the circuit and the phasor. Okay, this is phasor diagram, not the power triangle. So be careful. For power factor correction, there are three things: the circuit, phasor diagram, and the power triangle. If you give power triangle, you don't answer the question, so there is no mark. Okay, for the circuit, you just draw the supply. Okay, and then the inductive load, either you can do a box or put like this. Okay, and don't forget to label RL, and then you add capacitor. Okay, so this is C. So this is, you have I, okay, I source. This one is V source. Okay, and then this one is IC, and then this one is I load. Okay, this is how you draw the circuit. You get 1 mark for this. And then for the phasor diagram, okay, first you have to draw the voltage. Usually voltage you assume as a reference, so 0 degree Vs. And then the RL load, remember RL load is somewhere like this. Okay, this one is IL. Okay, and remember that IC is like this. Okay, 90 degree from Vs. So this is IC. Okay, and then you have to transfer this into this location. IC. Make sure it is horizontal, vertical. Okay, 90 degree horizontal, vertical. Okay, you cannot make it slightly to the left or to the right, because this is capacitance. Okay, and then you draw a new line, which is this one. Okay, this is IS. Okay, so if you draw this, you get 1 more mark, and then you have to explain. Okay, explain the answer. So this one, that what I just said. Okay, when you put the, okay, this one you have to explain. So this one 1 mark. When you put a capacitor, automatically the angle will be, okay, the angle, this is the theta 1, this one is theta 2. When you put capacitor, automatically theta is reduced. As a result, the power factor is reduced. Okay, so this one you get 1 more mark. So 1, 1, 1. So you get 3 marks. Next is the second question. Okay, construct a frequency domain equivalent circuit. So for this case, okay, you have to make sure that all the Henry and Farad changed to frequency domain. So where you get the frequency, so here. Okay, some of you don't know where you get the angular frequency. This is W. Okay, so first you have to calculate the value. So this one is ZC1 equals to negative J divided by WC1. So negative J is negative J, and then W is 200, taking from here. Okay. So multiply by 1.25 multiplied by 10 negative 3. Okay, many of you forget this. Okay, when it comes to milli, don't forget to do this. Okay. So you get the answer is negative 4J. Okay. So ZC2 is same thing, J divided by WC2. Negative J divided by 200 divided by 1 multiplied by 10 negative 3. Again, don't forget. Okay, many of you still forget to do this. If you forget this, all your answer will be wrong. So the answer is negative J5. Okay, ZL2 is JWL. So JWL is J200 and then 30 multiplied by 10. This one is 3. Okay, negative 3. So you get 6. Okay, 6. J6 ohm. Okay, this one is also ohm. Then ZL3 is equals to JWL. This one is 2. This one is 3. Okay, so J240 you get J8. So after you get that, next thing you have to draw everything again. Okay, when it comes to construct the frequency domain equivalent circuit, means that you have to draw again. Okay, so draw again this circuit. Okay, this one, if you don't draw, you can lose 2 marks. So draw, and don't forget to change the voltage source. Okay, equals to 340, and don't forget divide by square root 2 angle. So this one no phase, so 0 degree. Okay, so don't forget to convert this also. Okay, draw everything again and put all this value. This one you have to change, and change. This one also you have to change. Okay, next question is calculate the equivalent circuit across the voltage source. So you can see here, okay, so this is 6J. Okay, this is negative 5J, and then this one is 3 ohm. This one is Okay, for 0.42 angle 0. Okay, this one is J8, this one is 8, and C1 is negative J4. So negative J4. Okay, if you look here, this area can become, okay, this is in series, means that 6J plus negative J5, J5. So because this is in series, make sure it is plus, okay, and then this one has negative value, so become minus. So you get J. And this one also in series, means that it's just 8 plus J8. So this is Z3, okay, because if you look here, this is 3, right? So should be Z3. And this one should be 2 and 2, means that Z2. And then if you look here, okay, this one, you see that it is in parallel. Okay, so in parallel, you have to use the formula. Okay, so negative J4 is parallel with 3. So negative J4, 3 divide by 3 plus J. Negative J4 plus 3. So if you take this, the answer is so 1.92 minus 1.44 J. So I suggest you redraw again because you still don't familiar with this. So again, draw. So now impedance, you use box. Okay, box. And then box. So this one is J. Okay, this one is J. Z2, this one is Z1. It is 1.92 minus J is at 1.44. And then we see Z3, 8 plus J8. So you can see here, okay, this one is parallel to this one. Okay, so make sure you know how to determine which is parallel, which is series. If I draw this again, it's basically look like this. Okay, Z1, Z2, Z3. So what to do next? You have to make sure you parallel this. Okay, Z2 and Z3. Parallel with Z3. So equals to J parallel with 8 plus J8. Then divide by 8 plus J8 plus J. So the answer is answer is 0.055 plus J 0.94. Okay. Or 938. Okay. So then okay, you get this one. This is Z1. Then Z2 parallel with Z3. Then you just add together. So Z total or Z equivalent, use Z equivalent is equal to Z1 plus Z2 parallel with Z3 equals to okay, 1.92 minus J 1.44 plus 0.055 plus J 0.938. Okay. So the answer is okay, this one is correct. So equals to 0.9675 plus so this is minus 0.50. So don't forget J. So you get Z equivalent. Okay, this is how you calculate the equivalent circuit. And then prove that the current passing through this is 117.98 and this angle. So what is I2? If you look back here, this is I2. So basically you have to do a current division. Okay, use this one. Okay, this is I2. So you have I wait, check first. Oh, you have to calculate the I first, right? So this is IS. So IS is just equals to VS, okay, divided by Z equivalent. So just use the Ohm's law, you get the answer. So 240.41, right? For 1/2. So angle 0, okay, divide by 1 point, the Z equivalent, okay, this one, okay. You divide this and you get the answer. Okay, so I just show you lah. Take time to calculate. Okay, so this one is how to calculate the current. Okay, and then for the to get I2, so remember that this is I2. So you just use this is okay, wait. Okay, this one. So you have to use Ohm's law. Current division law. So I2 is basically, okay, remember, use the flip one. So you have to use this value, Z3. Okay, the opposite position. So Z2 plus Z3 IS. Or you can use another method is 1 over Z2. Okay, don't flip. Okay, this one you use Z3 and this one is used Z2. 1 over Z2 plus 1 over Z3 IS. So either way you get the same answer. Okay, if you look here, so this is one of the method. So you can insert the value and you get the answer. And for capacitor, of course, you just multiply by the, okay. Okay, after that you get the current, right? So you get the current, here. So just use Ohm's law. So V equals to VC2 equals to I2 multiplied by ZC2. Okay, make sure you use the Z value, not the C. Okay, the Henry. Not use the Farad. Use the impedance. Okay. Okay, for the next, okay, what is the power delivered by the source? I think this one is the easy one. Okay. So remember the formula P equals to V RMS, okay, or you just use VI cos theta V minus theta I, and make sure this is takes from complex, okay, complex number, the phasor, okay, the phasor number. So V you get the V is 240.41, right? Angle 0, and I is, you already calculated, IS is, so IS is, you look back here, is, okay, 117.98, angle 14.26. So you just take the magnitude, don't take the angle, the angle you just leave it. So 240.41, okay, multiply by 117.78 cos angle. Now you take the angle 0 minus, okay, 14.26. Okay. So if this one is positive, just leave like that. And if it is negative, make sure you put the negative. Okay, negative become positive. Okay. And then you get the answer. So the answer is 27.49 kilowatt. So for the question B, for this one, 3B, okay. So 3B, yeah, same formula, almost the same, but Q equals to V I S cos, not cos, use sine. Sine theta V minus theta I. So same things, same like this, but except this one you change to sine. So for this case, you get negative 6.99. Okay, remember that if you get negative, make sure you include the negative. Okay, some of you just cancel the negative. Okay, so make sure you include the negative. And lastly, okay, 3C, find the complex power of the circuit. So S, okay, the thick S, okay, P plus J Q. Just use this one. You don't need to calculate again. S equals to V I. So you can also use this. You get the same answer, but it is easy because you already calculate P and Q. So just insert the value, just 27.49 minus 7.49 minus J. Don't forget J for Q. 6.99 kVA. Okay. So for this one, okay, this is how you answer the question 3C. Okay, that's it for test 2. Do you have any question before we end? Hello?
No, doctor.
No question, eh? If you have any correction, make sure you inform me. Okay, because I think some of you have correction, and make sure you check back and calculate the mark given correctly. Okay, if there is no more question, we end our class. Okay, and make sure to check in your attendance. Okay, you can leave now.
Thank you, Doctor.
Okay, welcome.
Thank you, Doctor.
Thank you, Doctor.
Okay,
Thank you,
welcome.
Doctor.